The next skill I want to teach is looking at divisibility rules. Okay, we can say the divisibility rules. Now, these are rules of divisibility. So as we're looking at a number, I can look at most numbers right off the bat and say if there's a remainder or not. Pretty helpful skill when I'm doing my division work. So, first off, we start with 2. Okay? 2 into, say, 132. I automatically know there is no remainder because 2 goes into 132. 132 is divisible by 2 equally. How do I know that? 2 goes into every single even number there is in the world. So, the even numbers are just numbers that end in 2, 4, 6, 8, or 0. 2 can go into any of those because they're even numbers. So if that number ended in a 2, 2 can go into it. In a 4, in a 6, in an 8, or in a 0, 2 can go into it without any remainder. Now, with 5 and 10, those are our other 2 favorite numbers. 10, first of all, if you count by tens, there's something that you notice. 10, 20, 30, 40, 50, 60, it keeps going. Every single number that is divisible by 10 ends in a 0. So this is divisible by 10 because it ends in a 0. It is also divisible by 2 because any number that ends in 2, 4, 6, 8, or 0 is divisible by 2. Next we have 5. Okay. To remember the 5s, as you count by your 5s, 5, 10, 15, 20, 25, 30, you begin to see a pattern. So any number that ends in a 5 or a 0, 5 can go into. So all of those are divisible by 5 if it ends in a 0 or a 5, because those are the only numbers that 5 goes into equally. Those are the easy ones. Now, we get into some of the tricky ones, but also some of the fun ones. Okay, let's start with 9. 9's kind of fun. So, as I look at this, let's just do 342. I automatically know that 9 goes into that. How do I know? With 9, I add up the digits of the dividend. So I'm not saying 342 plus 0. No, I don't want to do that. I'm looking at the singular digits in the number. I add those together. Okay? 3 plus 4 is 7, plus 2 is 9. So if I add those digits together, and then 9 can go into the sum of these digits, it's divisible by 9. So 3 plus 4 plus 2 equals 9. 9 can go into 9, so 9 goes into 342. If I added 6 and 3, okay, 9 plus 6 is 15, plus 3 is 18. When I count by 9s, 9, 18, 9 can still go into that number because the sum of all these digits, singular digits added together, are a multiple of 9. Okay? What if I ended this in 9? Because then that would equal 27. Does 9 go into 27? Yes. So 9 goes into this number because the sum of all these little digits equals a multiple of 9. Okay? That's just a fun trick. Same with 3s, actually. Exact same with 3, except I'm not talking 9s here, I'm talking 3s. So does 3 go into 12 evenly? Well, let me check. What's 1 plus 2? It equals 3. Does 3 go into 3? Yes. Does 3 go into 125? Let's check. 1 plus 2 plus 5 equals 8. Does 3 go into 8 evenly? No. So 3 doesn't go into 125 evenly. 125 is not divisible by 3. Well, let's see. Does 3 go into 1,251? 1 plus 2 is 3, plus 5 is 8, plus 1 is 9. 3 goes into 9. So yes, no remainder with this. As long as you add these together, equal a multiple of 3, you're set. Okay. 6s. If you'll remember 2s and 3s, you can know whether it goes into 6. So first off, 6 can only go into even numbers. Sorry, only into even numbers. So let's just throw an even number there. any 2, 4, 6, 8, or 0. So then it has to work for 3. So let's say 114. Does that work? Yes, because 1 plus 1 plus 4 equals 6. 3 goes into 6. How about 3,114? Well, 3 plus 1 plus 1 plus 4 is 9. 3 goes into 9. So it works for 2 because the last digit is an even number, and it works for 3 because the digits are a multiple of 3. And so that's the basic divisibility rules for the easy ones: 2, 3, 5, 6, and 10. 9 and 10.